Hey math kids, today we're going to talk about arithmetic sequences, and we are in section 5B in your book, and we will be starting with example 2. The first thing is just what is an arithmetic sequence. In the previous video, the sequence we saw was arithmetic. So all it means is that we add the same number over and over and over to get to the next term. So we'll add 3, add 3, add 3, add 3, or add 5, add 5, add 5. And so let's get started with this. So we have 2, 9, 16, 23, and 30. So in this sequence, we want to find something called the common difference first. And all that is, it's D. We'll see some formulas in a little bit. And it's the amount that you're changing by. So since we're adding 7, our D, or our common difference, is 7. And that's really all we need to do to show that this is arithmetic. So part A on this says show that it's arithmetic. And so we're showing that the D is 7, so it's arithmetic. Now B says find a formula for the general term U sub n. Now if you look just a little bit up in your book, in a blue box, you'll see this. Okay, so this is the general term. And so what we're going to do is we're going to do a few things. So U1 is the first term. N is the total number of terms. So in this case, 1, 2, 3, 4, 5. And D, we already have right here. And so we can just plug everything in. So this is U sub n, but since we have 5 terms, it's U sub 5. Oh wait, we want to do the general term, sorry. So we're going to keep it general. I was getting a little ahead of myself. So n is like the term you're looking at. So this is the first term, the second term, third, fourth, fifth. So n is 4 here, 3 here, 2 here, 5 here. Okay, so U1 is 2, n is still n, and then D is 7. So, we can leave it like this, or we can simplify it a little bit. So let's distribute the 7. So we have 2 plus 7n minus 7. Combine those two, we get negative 5 plus 7n is the nth term formula. Okay. Now part C says find the 100th term of the sequence. So once we have this formula, it's pretty easy to find U100, because that would be the 100th term. So we just take this, negative 5 plus 7 times 100. So 7 times 100 is 700. Then if we subtract 5 from that, we get 695. And so the 100th term is 695. Okay. And now we have part D, and it's asking us if either of these numbers are in the sequence. So we have 828, and we also have 2,341. So the way that we do this is we actually use this formula right here, and we plug this in as if it were a term. So we plug it in right here, and then we solve for n. If n is a whole number, then it is a term. If it's not a whole number, then it's not. So we need to add 5 to both sides. So it's going to be 833, which equals 7n. Divide by 7, divide by 7. I'm going to do that on a calculator. I don't know why this isn't working. Alright, I guess I can't use that calculator to do it. It actually ends up being n is 119. And since that's a whole number, we say yes, 828 is in the sequence. Okay, so we come back up to this. All right, now we're going to test this one in a similar way. So 2,341 equals negative 5 plus 7n. Once again, I'm using this equation. So I add 5 to both sides. 2, 3, 4, 6 equals 7n. Divide by 7, divide by 7. And n equals 3, 3, and 1/7. So since that is not a whole number, we say that 2,341 isn't in the sequence. Okay? All right, now we're going to move on to example 3. And it says find k given that 3k plus 1 comma k comma negative 3 are consecutive terms of an arithmetic sequence. Okay. So we're going to have to go back to the idea of d. So remember, d is the common difference. So we know that the distance from here to here is d, and the distance from here to here is also d. So if we just take this minus this, so we say k minus 3k plus 1, that would equal d. Or if we take this minus this, negative 3 minus k, those should equal the same thing. Since they both equal d, we can set them equal to each other. So k minus 3k plus 1 equals negative 3 minus k. Now, all we have to do is simplify and solve for k. So we want to distribute this negative. And then we want to start getting things on the same, well, here, let's combine these first. So that's negative 2k minus 1, negative 3 minus k. Now, I'm just going to choose my left side to be the side that I get k onto. So I'm going to add k, then I'm going to subtract, or add 1. So these cancel. And if we simplify, we get negative k equals negative 2, or k equals 2. And that's all we had to do on that one. So now let's move on to example 4. It says find the general term formula u sub n. So find u sub n for an arithmetic sequence with u3 equal to 8 and u8 equal to negative 17. Okay, so we're going to create a couple different formulas. So we're going to go back to that formula that we had at the beginning, where we had u1 plus n minus 1 times d. And we're going to create a couple formulas for this. So we have u3 is equal to u1 plus n, which would be 3 in this case, and then times d. And we know what u3 is, so we can actually just replace u3 with its value, which is 8. Now we'll do the same thing with u8. So negative 17 equals u1 plus, our n now is 8, and d. So since we have two equations and two unknowns, we theoretically can solve this. And so if we just multiply, we have u1s right here. So the easiest thing to do is probably just multiply everything on the top. Let's see the bottom. Everything on the bottom by -1. So I'm just going to do that. -1, -1, -1. So when we do that, our top is still the same. But I'm going to simplify this. So 3 minus 1 is 2. So we have 2d. If we multiply that, we get positive 17. If we multiply that, we get negative u1. And this would be a 7, but then multiplied by a negative, it would be -7. Now, we just add these. This is using the elimination method, if you remember that. Those cancel because they're opposite. Then we add these together and we get 25. And then this becomes -5d. And so if we just divide both sides by -5, we end up with -5. So that definitely sounds like it's backwards, right? Because we're thinking of it as addition, but with a arithmetic sequence, it's okay to have a negative. That just means we're decreasing. And we saw that here. So we started off with 8, and then we ended up with -17, so we have a decreasing. So that just means we're subtracting the same amount, and in this case we're subtracting 5 each time. Okay? And we can check this if we want, or we can just leave it. The book has a check, so you can look at how to check that if you want to, but we're going to keep moving on to example 5.